Hello.
Yeah, hi. So we will discuss integral calculus. Unless you
Yes.
have some doubts before that, if you have anything, you can ask me.
One Fritzy class they taught differential equations, and I
Okay.
didn't understand that.
That is because you don't know integral calculus yet. So we'll do this after that, it will be fine. What did they teach? They said that you can find if derivative is given,
Yeah, yeah.
then you can find the y, right?
Yes.
So it is basically integration only. So if derivative is given, you can find the y, and they would have said something like this. And you will say x power 4 by 4, integrate both sides, y is b plus x plus
Yeah.
c, and then
And
some.
they give some other equation also. One second, I'll just take that out. And integration also, like many questions, I had doubts.
Okay, so integral calculus you have to understand anyway, so we'll discuss
Yeah.
that today. So once you understand theoretically, after that it will be clear. So
Yeah.
other than that, chemistry, physics, and all,
Chemistry, I had one doubt.
what is this about?
It's balancing only, but like it's not coming. Many people tried, but it's not coming.
What is it?
So it's like Zn plus HNO3
Mm-hmm.
gives ZnNO3 whole twice.
Many people tried, doesn't?
Like my friend called me like because she didn't get it and then I didn't get it and then she called many other people.
What is happening? Good. Okay. Many people have been trying this one particular equation. Huh?
Yeah.
Okay. Okay. Then,
Plus
ZNO3
N2
voltage plus,
plus N2
huh,
plus H2.
that's it. Huh?
Yeah, that's
Okay. So, okay. Okay. Um, what happens here? Nitrogen is balanced right? No, nitrogen is not balanced right now. 2 and 4, nitrogen is balanced right now. And hydrogen, zinc is balanced right now. Oxygen is 6, 2, 8, 1, 9. And oxygen is 18 there. So 6, 2, 8, and 10. Okay. So it's a problem. Oxygen is a problem right now. So everything else is balanced except oxygen. Zinc and nitrogen are definitely balanced right now. So
yeah.
can we balance oxygens properly? So let's follow the method to balance oxygen. Add H2O on the side that doesn't have enough H2O, right?
Yeah.
So 18 O's here, 6 O's here,
12. Yeah,
and 2
6,
8
8,
here, right?
9, 12. Yeah.
So you can make 10 H2O here, right?
Yes.
10 H2O here, and okay. Okay, basically you will have to split it into half reactions into it, because this side then there will be 20 to 6, you have to add H plus. So then electrons will not be balanced. Fine. So fine. Zinc is clearly being oxidized,
Yes.
right? Zinc
Yeah.
is going from 0 to 2,
Yeah.
and nitrogen here is minus plus 5,
Plus 5 to
and here
plus 1.
nitrogen is, there are two products, one of them is NO3 minus, so plus 5, and here it is becoming uh,
Plus 1.
plus 1, right?
Yeah.
So we have Zn plus HNO3 becomes ZnNO3 whole twice plus N2O plus H2O. So nitrogen is losing from +5 to +1 here.
Yeah. Yeah.
So loss is 4 and zinc is gaining 2, right? So
Yeah.
the zinc quantity will be double of the nitrogen quantity, because then only you can match the losses, right?
Yes.
Correct. So for example, here, if you have NO3 here, there is 2 N's here and 2 N's here. So it should be 4 HNO3 for sure, right?
Yeah.
Correct.
Yes.
And 4 HNO3. So how much is the loss now? 2 of the nitrogens are at +1, and so 8 is the loss, right? Because this
Yeah.
was +5. 4 of them were at
Yes.
+5, and there are 2 of them are at +5 and 2 of them are +1, right?
Yes.
So 8 is the loss, and zinc is becoming +2 only, right? So 4 zinc has to happen. So 4 zinc. So 4 zinc,
Yeah.
and okay. So fine. So now what happens is, then there are too many nitrogens here, right? If you have 4 zinc, okay, too many nitrogens here. Okay. So oxidation number method does not seem to be helping much. Okay. So Zn gives ZnNO3 whole twice. Zn plus HNO3 gives ZnNO3 whole twice. Is one reaction. Twice. And HNO3 gives N2O.
Plus H2.
H2O is the reduction reaction. Okay. Okay. So here I have to balance for everything else. So 2 I will do first to balance for nitrogen,
Yeah.
and
And
everything
then
else. So
it's
6 oxygen here, 6 oxygen here, H is here,
so
and
2
H is more missing. So I have to add a
plus
H plus on this side, right?
2H.
Right? And
Yeah.
then I have to add a 2 electrons on this side, right? Right?
Yeah.
Then it will charge is balanced.
Yeah.
And this side 2 HNO3 to balance the N. 2H. So okay, oxygen is 6 and oxygen is 2.
2.
So I have to add 4 H2O. So this becomes 5 H2O, and 10 and 2. So plus 8 H plus, right?
Yeah.
So plus 8 electron, right? Oh wait, why
Yeah.
am I adding electrons on both sides? I have to add electrons on this side. No, this is wrong.
Only to balance it. Yeah.
Only to balance the charge, right?
Charge.
Correct. Now multiply
Yes.
this equation by 4 times to cancel the electrons.
Yes.
4 plus 8 is 4 plus 8, 8, correct? Plus
Yeah.
8, right?
Yeah.
I multiply this by 2. So 4 plus 16. No, multiply nothing you have to do, right?
Like it's same.
It's the same, right?
Same.
2
Yeah.
HNO3 gives 8 H plus 8 electrons, right? So it
Yeah.
becomes 4 Zn plus 10 HNO3, right? Plus how many H plus? 8 H plus gets cancelled.
Yes. Cancel. Yeah.
8 electrons get cancelled.
Yes.
Gives
Yeah.
4 ZnNO3 whole twice plus N2O plus 5 H2. So now check whether everything is balanced. 10 nitrogens and
Yes.
8 nitrogens and 10 nitrogens. hydrogen 10 hydrogens, 10 hydrogens. Oxygens, there are 30 oxygens. 6 fours are 24 plus 1 plus 5. Everything is balanced.
Yeah, that's the answer. Like, yeah, that's the answer.
So how have I done it? I decided to split uh, it into half reactions. So which is my oxidation part? Zn plus gives Zn2 plus. But if you just wrote Zn gives Zn2 plus, then you will never be able to get the NO3 and all. No? So you understand, you cannot write Zn gives Zn2 plus and that's it, right?
Yes, yes,
You
yes.
have to use the NO3 part. Zn plus and HNO3 is causing the oxidation of zinc, right? So
Yes,
write the
understood.
complete half reaction, and zinc is not involved in the reduction of this. Uh,
Hmm.
the reduction part is HNO3 is becoming N2O plus H2O. So
Yes.
that is the other half reaction. Now this half reaction, I did normal methods of balancing. I did normal stuff, nothing weird, and added 2 electrons to balance charge. This side I did again normal stuff, nothing weird, added 8 electrons here, and then just made sure that the electrons cancelled, right?
Yeah. Okay. Got it.
Okay.
Fine.
Uh, what
Not,
else?
nothing else in chemistry or physics.
Okay. So what is happening right now in Fitchi? What are you teaching in chemistry?
Chemistry we have only on Saturday and Sunday.
So right now, what
And
are the topics that are happening?
in chemistry, the non-mality thing I had to.
Okay, acids and bases and all they're doing.
Yeah, yeah, yeah. That.
And in physics, what are they doing?
In physics, they started kinematics. That was the last class.
Hmm.
And today, we had maths, but I left halfway through because they were teaching determinants and all, and like very fast and properties and all. Like I didn't understand, so I thought, like, why would
Hmm.
I simply sit when I don't understand? So I.
So they are teaching determinants and properties.
Yeah, the properties of determinants, and they started straight lines.
They started
Like,
straight lines.
yeah, they did half differential equations and brief of straight lines,
Hmm.
like whatever we had done last year.
Hmm.
And they started determinants and using that area of triangle
Hmm. Okay.
and the properties.
Okay. So that's fine. So we have done trigonometry, right? We have done trigonometry
Yeah.
is over for us. If we do that one class of last class of properties of triangle, the revision class, right?
Yes. Yes.
So
Yes.
trigonometry is over for us. So next week we can also start straight lines. So then we'll do straight lines, circle, parabola, ellipse, hyperbola. So this is the sequence in which Vidji will do it. They will first do straight line, circle, parabola, ellipse, hyperbola. Then they will go to algebra. Okay. So they might go till here and then stop and then do algebra and then do these later. But this is the sequence that Fitji follows. This is phase one, I think.
Yeah. Yeah.
Phase one is starting with straight lines. You know. Okay. Uh, that's fine. Uh, and in physics, they started kinematics.
Yeah. Just the like equations of motion.
Okay. Okay, fine. So let's do our integral calculus. Uh, what is this? Basically, integral calculus is a subject that has been there to decide what is the area under this particular curve.
Hmm.
What is this is the geometrical meaning of integration. So suppose you have to find from x is equal to 0 to x is equal to a. This is some function y is equal to fx. Someone asked you what is the
Yeah.
area under the function and up to the x-axis. What is that value of the area, right? Now,
Hmm.
this is not an easy question because you don't have any formulas that will help you here, right?
Yeah.
No formula
Yes.
will give you the area directly. This is curved, right? So it can be
Yes.
weird, like we don't know how to calculate the area. So
Yeah.
in general, when we did not know calculus, pre-calculus times, there was no way to do this. But after people understood and figured out calculus, then there is a nice and easy way to do this area calculation. So basically you will be able to find area under any curve. So in a similar manner, now you will be able to find area under a quadrant of a circle. So suppose I do this. Suppose I draw a circle like this, right? One quadrant of a circle, right?
Yeah.
This is circle can be in four parts, but I have taken just one quadrant, right?
Yes. Okay.
So this is a circle, and if you wanted to find the area under this circle, correct? So we can still find that out, right?
Yeah.
I mean, if you right now we can't find it out right now unless we know the circle formula. We don't know how to find it, but with calculus, you will be able to derive the area of the circle of this portion is equal to pi by 4 into r square. So this will tell you that the whole quadrant will be just pi r square. So we are not talking about using a formula to get the answer. We are talking about actually deriving how the formula comes. Okay, so that is a different thing altogether, right? So right now you cannot prove that area of a circle is pi r square, right?
Yeah.
You can't prove it. People have just told you and you have accepted it, right?
Yes.
So with calculus, you will be able to prove that a quadrant of the circle, this much area will be pi by 4 r square, and because it is symmetrical and in a circle there are 4 such quadrants, the total area becomes pi r square, right?
Yeah.
So calculus and integral calculus especially is very powerful, and it helps us do these things. So what we will do is we'll try and understand how this happens, right? So
yeah.
So far what we have done is we have understood derivatives. We have understood so far. So now we will understand something called an antiderivative. What is an antiderivative? It is, as the word suggests, name suggests, it is the opposite of a derivative. So for example, if you had a function y is equal to x square, the derivative y dash would be 2x.
Yeah.
Right? So if someone had given you the function this and asked you what is the derivative of this, right? What is the derivative of this function? You would have said y, new function. So fx suppose is equal to x square. If someone asks what is the derivative, gx is equal to f dash x, what is find gx? You would have easily said derivative is 2x, right? You would have found gx is equal to 2x, right?
Yes.
This we have understood last class, and we have figured out how it comes, and it is limit of x h tends to 0 f of x plus h minus. So how does it come? Limit of h tends to 0 f of x plus h minus f of x by h, right? So when you do this, so see, it will come very easily. So fx is this, so it is x plus h whole square. X plus h whole square minus x square by h, right? So limit of h tends to 0. So when you do the calculation, this becomes h square plus 2xh by h, right? Limit of h tends to 0. Now h cancels once, right? So it is just h plus 2x, right? And limit of h tends to 0, that becomes 2x.
2x,
right? So that is how it comes, and we know rules of differentiation and all, right? So, but now suppose somebody had given you the opposite question. Opposite question is, somebody had given you d of f by d of x is equal to 2x and asked you what is fx. You understand? So they have given you gx, suppose gx was known to you, 2x, and they are asking you what is fx, right? So that process is called taking an integral or taking an antiderivative. You are doing an antiderivative, no, opposite of that, right?
Yes.
That process is called taking an integral, finding an integral. So what is the function whose derivative is this? Correct? So a question, this can be written as, this question can be written as integral of, this question can be written as integral of 2x with respect to x. Dx means just the variable is x, is what? This is the question. Okay, this taking an antiderivative is denoted by this sign. Okay, this is an integral sign. Okay,
Yeah.
so the meaning of this notation is find the function whose derivative is 2x.
Yeah.
Okay.
Yes.
Okay. So this process is generally like a guessing thing. Now you have to guess what function will make your derivative 2x. So you will guess ki if I had differentiated x square, then it would have become 2x, right? So so seems like x square is the function. So you would guess that it could be x square, right?
Yeah.
But isn't it also x square plus 1? What happens if you differentiate x square plus 1?
2x. Yeah.
So this is also giving 2x. X square plus
Yeah.
2 will also give 2x. X square will
Yes.
also give 2x, right? So there are many such functions, no?
Yes.
Many possible functions which will give 2x upon differentiation, right?
Yes.
Correct. So
Yeah.
this is, therefore you don't know for sure which is which, right? Which one exactly you were referring to, right? So
Yes.
when you take the antiderivative, you get a possible set of antiderivatives that is infinite in number, because all of those possible antiderivatives differ by a constant. Okay, so what we write is integral of 2x dx is equal to x square plus some constant. We don't know the constant yet. Okay, because any constant will fit, no? Any constant, if you take
Yes.
x square plus c, if you differentiate, it becomes 2x, right?
Yes.
Correct.
Yeah.
Makes sense, no?
Yes. Yes.
Okay, so
Yeah, they gave us the formula for like the x to the n plus 1 by n plus 1.
we'll discuss all of that. So right
Yeah.
now what we are just seeing is how this became this, right? So this is sort of like a guessing thing. So if you think about x power n dx, right? What
Yeah.
function, this means what? The question is, what function should I choose whose differentiation is x power n, right? So
Yeah.
if you do trial and error and see x power n plus 1, to differentiate it becomes n plus 1 into x power n, right?
Yes.
So
Yes.
some part of it has matched, but there is an extra factor of n plus 1. No? So one way to do it would be if I had started off with some by n plus 1, right? Then that extra factor would have cancelled off, right?
Yes. Yes.
So if I started off by differentiating this, then I would have gotten x power n, right? So the answer for this is x power n plus 1 by n plus 1 plus c. Plus c I'm adding because plus 1, plus 2, plus 3 and all doesn't matter.
Yeah.
Right?
Okay.
All of that is fine. No, all of the other functions with plus 1, plus 2 are still going to give the same result.
Yeah. Okay.
Okay.
Yes.
So those are also possible. So okay, so this is like just the basic understanding. So for example, now sine x dx, you are basically asking the question, which function would you differentiate to get sine x, right? If I differentiated cos x, I would have gotten minus sine x, no? So if I started with minus cos x, if I differentiate minus cos x, I will get sine x, no?
Yes. Yes.
So the answer is this, right? So similarly, the which function would you differentiate to get this, right? Cos x, right? Sin x, if I differentiate, I'll get cos x, right? So you are understanding the meaning of it. The meaning of this symbol is basically find a function whose differentiation is cos x, whose differentiation is sin x, okay? And you get the answers by guessing. This is just a guessing method, right? So and you can build up a table of integrals that you can see, right? So x power n dx is equal to x power n plus 1 by n plus 1 dx plus c, right? Integral of sin x dx is minus cos x plus c. Integral of cos x dx is sin x plus c. And integral of secant square x dx. So think of what derivative, whose derivative is secant square x?
Tan.
Tan on differentiation gives secant square. So tan x plus c.
Yeah.
right?
Yes.
Correct, and so on. You can build some formulas, some 9-10 formulas can come, right?
Yeah.
But the point that we are trying to understand here is not just like getting a list of formulas. What we are trying to understand is how that makes sense and why is it area under the curve, right? Ultimately, what we want to understand is why is this formula area under the curve, right? And
Yes.
this is so far just guessing, right? This is guessing, right? We want a method for it. We don't want to just guess, right?
Okay.
We want a rigorous method. This is not a mathematically sound argument. No, this is like guessing. Like if I give you a different function, you will be stumped, right?
Oh.
You understand? If I give you some sine square x, you will not be able to guess immediately. You will not fail to guess, right?
Yeah.
Or some more complicated function, it will be bad, right? So what we want is some general mathematical meaning to this, right? So the mathematical meaning to this comes from area under the curve. Okay. Okay. So area under the curve. So let's try to understand. Let's try to understand what is area under the curve. Let's take a simple function. Let's take a simple function y is equal to x, right? Why have I chosen this function? Because directly I can find the area under this without using any formulas and all.
Yeah.
You understand? Because 0 to 1, I can find area because it is a triangle. No? There is no problem.
Yeah. The half. Yeah.
This is an easy area to find out. So I can verify my answers here, right?
Yes.
Correct.
Yes.
So 0 to 1, my answer is easily known. It is equal to half into 1 into 1, right? Area is half, right?
Yes.
So now I will try to come up with the answer by a standard method that I will use again and again. Okay. So let's try to figure out a method. So what I will do is, okay, first of all, I will show you one thing. First of all, I will show you that if you did integral of x dx, no? Integral of x dx, what function would you have guessed for x dx? Whose derivative is x?
Like x squared by 2.
X squared by 2, right? X squared by 2 makes sense because when you differentiate this, it becomes 2x by 2, no? So that is x.
Yes.
Right?
Yes.
So this is the perfect function for it. Now let's check one thing. X squared by 2, let's evaluate from 0 to 1. Okay. By evaluate, what I mean is put the final value and subtract it from the initial value. Okay. So x squared by 2, evaluation of 0 to 1 means put 1 square by 2 minus 0 square by 2. What is it? 1 by 2.
1 by 2.
So this thing is written as 0 to 1 x dx. If I write 0 to 1 x dx, I mean first do the antiderivative, which is x squared by 2 plus constant, right? And then put initial and final values. Okay. So for final value is 1 square by 2 plus c minus initial value is 0 square by 2 plus c, and c cancels out. It is 1 by 2. Right? Correct.
Okay. Yeah.
If I had to find the area from 1 to 2, right? Let's actually find the area by common sense and geometry. Let's say find the area from there. So this height is 2, right? And this height is 1. And this distance is 1, right?
Yeah.
This is a trapezium. Trapezium area is half into sum of parallel sides. So 1 plus 2.
1 plus
into distance between them, which is 1.
1, yeah.
Correct. So the actual area should be 3 by 2, right? Correct.
Yeah. Yes.
This is the area of this trapezium, no?
Yes. Yes.
Now let's check whether we are getting integral 1 to 2 x dx, what comes. Okay. So this becomes x squared by 2 plus c from 1 to 2, right? C gets cancelled, so we don't need to bother about it. So we do 2 square by 2 minus 1 square by 2.
Yeah. Yeah. 3 by 2.
3 by 2, right? So we are noticing some nice pattern. Nice pattern is that if you take the antiderivative, right, and calculate antiderivatives values from one place to one place and subtract, right, the difference, right? that is giving us the area under the curve, right?
Yes.
You are seeing this pattern. Two times it has worked, and it will work every time. Okay. The
Yeah.
reason why I have chosen this function is because there is an alternate way to get the area here, right? But
Yes.
if I had chosen some curve, then there is no way that you would believe me that area is this, right? Here at least it is believable because we can verify by a second method, right?
Yes.
Makes sense. So
Yeah. Got it.
now I want to get this in a slightly different way, like not in this guessing method. Like we guessed that integral by just knowing things, knowing that integral is this, right?
Yeah.
Like I just randomly guessed that x squared by 2 and it worked, right?
Yes.
But if the function was a little more complicated, I would not have been able to guess, right? So
Yeah.
it's all fine as long if you have been able to guess, then you don't need to worry about it. If you found the antiderivative, then your job is done. But if you cannot guess immediately, right, then there is a standard method to get it. Okay, that standard method is what we learn. So suppose you have this y is equal to x, right? Okay,
Yeah.
y is equal to x. We want the area between x is equal to 1 and x is equal to 2. Okay,
Yeah.
area between x is equal to 1 and x is equal to 2. So we know already that the area is 3 by 2. We want to see if we can derive it in some way without using the fact that it is just 1 to 2 x dx, which is, we know the answer is this. Without using this fact, we want to get it. Correct?
Yes.
So in general, if you are unable to guess this, then how would you have done, right? That is what we are figuring out. Okay.
Yes.
So the standard method is to, okay, I want to find the area between this region, right? So this region I will partition or I will divide into n tiny spots.
Okay.
Okay, n partitions. Okay, so what is the total width of the region? Total width is 2 minus 1, so it is 1, right? So
Yeah.
what is the width of each line segment here? Each segment here, for example, width is equal to 1 by n, right?
Yeah.
Now
Yes.
make rectangles. Okay, make rectangles like this.
Okay.
Okay. Make many rectangles. You understand what I'm doing? I'm just making rectangles like this. Each partition that you have created, no, draw vertical lines basically from there. So we'll end up forming many rectangles, no?
Yes.
Correct.
Yeah. Yeah.
These are the rectangles. Okay. So what we want to do is we want to get the area under the curve. So what we will say is area under the curve will approximately be equal to the sum of the areas of all the rectangles, right?
Yeah. Yeah.
Correct. Now the problem is that actually it is not a rectangle. Notice that this is a trapezium, no, again.
Yeah. Correct. Yes.
Right? Actually it is a trapezium, no? What we will do though is we'll not bother about trapezium and stuff. We'll just say this like this.
Consider
Consider it a rectangle. We'll not bother. Okay.
Yes.
So what do we need to find area of any one rectangle? Let's figure it out. Okay. So its x position starts from 1, right? This is 1, right? What is the next point? 1 plus 1 by n, right? The width, the end of the rectangle is 1 plus 1 by n, no?
Yeah.
Right? So what is the height of the rectangle? It is the value at 1, right?
Yeah, the graph.
The graph's height at 1, no? So right now I'm considering lower rectangles. You understand what I mean by lower rectangles from this one? I could have also taken upper rectangles like this. You understand?
Yeah, I got it.
So the area of the rectangle can be taken using this height or using this height, right? It is a choice that is independent. You can make that choice. Okay. Correct. Because basically this trapezium can be shown as this rectangle or also shown as this higher height rectangle, right?
Yeah.
This height or this height, right? That is up to you. Okay. So what will happen is if I choose lower height, my area will be an underestimate, right? You understand? If I choose lower height, I'm losing out on area. If I choose greater height, then I'm adding some unnecessary area.
Yeah.
Right. So
Yes.
there will be an error anyway. So right now we'll go with the lower heights. Okay. So what is the height of this? It is 1, no, at this point. Correct.
Yeah. Yeah.
And height of this one will be 1 plus 1 by n, the second rectangle.
Yes.
Third rectangle will be 1 plus 2 by n, because y is equal to x, right?
Yeah. Yeah.
This is the third rectangle, this is the second rectangle, this is the first rectangle, right?
First.
So what we are
Yeah.
getting is height of ith rectangle should be 1 plus I minus 1 into 1 by n, no?
Yeah.
Because
Yeah.
the first rectangle is 1 only, second rectangle is 1 plus 1 by n is the height, right?
Yes.
Correct. The
Yes.
third rectangle
Yes.
is right. So height of ith rectangle is this. What is the width of the rectangle? This base, that is same for every rectangle, it is 1 by n.
Yeah.
So area, width into height, length into breadth is the area, right? Area of the ith rectangle, this is
Yes. Got it.
correct. So
Yes.
this is area of ith rectangle. Now what you have to do is add up all such rectangles, right? How many rectangles have we made? We have made n rectangles, right? Correct.
Yeah. Yeah.
N rectangles. So I will start from 1, right? So because the first rectangle was I was 1, so I minus 1 became 0, right? You understand?
Yes.
First rectangle
Yeah.
was when I was 1, and finally you will end up with the nth rectangle where I this height is 1 plus n minus 1 by n, right?
Yeah.
So I'm going to do summation of all the AIs, right? I goes from 1 to n, right?
Yes.
Makes sense?
Yeah.
That is my approximate area. Okay, right?
Yeah.
Correct. Approximate
Yes.
area is just the sum of all the rectangles. So now what I will do is I will try to do this summation. Okay. So this is what? This is summation I is equal to 1 to n 1 plus I minus 1 by n into 1 by n, right? Correct. So
Yes.
summation from 1 to n. So now how many times, okay, let's just simplify it a little bit. 1 by n plus 1 by n square into I minus 1, right? It. So I'm trying to sum it, right? So what I will get is 1 by n, if you add n times, it becomes 1, no? This one, this part.
Yeah. Yeah. Correct. Yes.
Plus, now what you get is summation I goes from 1 to n, right? 1 by n square, I minus 1. This 1 by n square is constant for each, right?
Yes.
Each term will
Yeah.
have 1 by n square, no? So 1 by n square doesn't bother us. 1 by n square
Yeah.
goes outside, and its summation I goes from 1 to n of I minus 1, right?
Yeah.
Correct. And
Yeah.
1 plus, right? So I for sum of first 10 natural numbers, you know, no?
N into n plus 1
It's
by
1
2.
by 2, right? So I'll
Yes.
write this summation as n into n plus 1 by 2 and subtract minus n from it, because 1, 1, 1 n times, right? And
Yes.
divide by n square like this, correct? And add a
Yeah.
1, right? So 1 n gets cancelled here, right? And 1 n comes inside. So it is 1 plus 1 by n by 2 minus 1 by n, right?
Yeah.
Correct?
Yes.
And 1
Yeah.
plus, right?
Huh.
So this becomes 1 plus 1 by 2. So 3 by 2 plus 1 by 2n minus 1 by n, correct?
Yeah. Yeah.
We're getting 3 by 2 minus 1 by 2n,
Yeah. Yeah.
right?
Yes.
After doing the addition and all.
Yeah.
So
Yeah.
area comes out to be, total area, summation of area comes out to be 3 by 2 minus 1
Minus.
by 2n, right?
Yeah.
Right. Now notice what you can deduce from this formula. This formula is telling us that area is always going to be less than 3 by 2, right?
Ah. Yeah.
Right.
Correct.
And
Yes.
how much is it less than 3 by 2? It is less than 3 by 2 by this amount, right?
Yes.
So isn't
Got
this telling you the error in the area, because actual area is 3 by 2, see?
it. Okay.
Right? So
Uh-huh.
now we also know a method to remove the error entirely, right? Now we know a method is take limit n tends to infinity of this summation of the areas, right? Because what does that mean? Limit n tends to infinity means right now I had chosen n rectangles, no? Now I will choose how many rectangles? I will choose n becomes very large, infinite, right? So
Yes.
suppose instead of the 10 or so rectangles that I chose here, I will choose 100,000 rectangles, right? And
Very
imagine
good.
the thinness of that rectangle.
Yes.
You understand? It is so
Yes.
thin, no? If it is really thin, the rectangle, then the error is also really small, no? You understand?
Yeah. Yeah.
If you take a very big rectangle, no, then it's a huge error. You understand? See?
Uh,
If I take a
yeah.
rectangle like this, the error is so much, no? But if you take a tiny, like almost negligible thickness rectangle, right? Then the error is
Yes.
really small, right?
Yeah. Got it.
In the condition that you take n tends to infinity, the sum of the areas of the n rectangles will become the actual area, real area,
Yes.
because the error becomes close to zero. So what happens here, when you take n tends to infinity, what happens to this expression? See,
Becomes
3 by 2 minus 1 by 2n becomes 3 by 2 only, no? Because this becomes 0. No?
that becomes 0.
This
Yeah.
part tends to 0. This part is the error. Okay.
Yes.
So
Yes.
now we are confirming our prediction that area was 3 by 2.
Got it. Understood.
We didn't need to know the geometry to find this area. See, this had come, no, for us.
Yeah.
And we would have taken, let's make our rectangles thinner and thinner, and limit tends to infinity, the area becomes 3 by 2, right?
Yes.
You would have said this is the actual area, and with full confidence, we don't even need to check the geometry. This comes, right?
Yes. Correct.
So now let's do one more example so that it is a little more clearer. In this case, now we'll not know the actual area. Okay, I don't know how to find the actual area. Curve is y is equal to x square. Okay, and you have to find the area between 0 to 2. Okay, area of
Yeah.
under the curve from 0 to 2, right?
Okay.
Okay, so now we'll follow our method again. We'll divide 0 to 2 into n parts. Each part has width is equal to 2 by n, right?
Right. Yeah.
Correct. 2 by n is
Yeah.
the width. And now we'll say I will make rectangles like this. Many n rectangles I'll make. Okay. Correct. And let's
Yeah.
find the area of one such rectangle. Okay. So what are the
So that
x points here? First point is 0. Then second point is 2 by n. Then
I
third point
am.
is 4 by n. And then 6 by n. And this last point will be 2 into n minus 1 by n, and then it becomes 2n by n, right?
Yeah.
Correct. So
Yes.
if I, this is my first rectangle. If I take lower areas, like this, first rectangle has height 0, right?
Yeah.
Right, because it starts from 0, no?
Yes.
So
Yes.
second rectangle is this, third rectangle is this, fourth rectangle is this, and so on, right? So let's focus our attention on the second rectangle, area of the second rectangle. So what is the height of the second rectangle, right? So its x position is 2 by n, no?
I am.
So what is the y
Yeah.
of it? Y of it will be 2 by n whole square.
Yeah.
Height of it,
Yeah.
because the curve is y is
That's
equal to x square. Correct?
yes.
And the width of it is 2 by n, no? Base is 2 by n.
Yes.
Correct. Let's look at our third rectangle. Okay. So its x position is 4 by n, no? 4 by n here, right?
Yeah. Yeah.
So its height will be 4 by n whole square, and width will be 2 by n. Correct?
Yes.
Correct, no?
Yeah.
So,
Yes.
so
Good.
area of ith rectangle would be, see, 3 was 2. So 2 into 2. So this is 2 into 1. So this will be 2 into I minus 1, right?
Okay.
So what I'm saying
Yeah.
is the pattern is what? 2 into 1, 2 into 2, 2 into
Yeah.
I minus 1, no? Inside.
Yes.
right?
Got it.
So this is the height and this is the width, right? Correct.
Yes.
So what I have to
Yeah.
do now is I goes from 1 to n, right? N such rectangles are there, right?
Yes.
So
Yes.
1 to n, I have to add up all the areas, right? So it is, let's take 2 by n outside. So 4 by n squares multiplied by 2 by n becomes 8 by n cube comes outside, and you have to do I minus 1 whole square, right?
Yeah.
This is the summation. I have to add up all such areas, no?
Yes.
So my
Okay.
summation is this thing. Just follow this, right? So
Yeah.
8 by n cube comes outside, and my summation is I is equal to 1 to n of this thing, which if you expand, what will it look like?
Expert.
0 square plus 1 square plus 2 square plus n minus 1 square, no?
Yeah. Yeah.
Right?
But by
Because I is equal to 1 to n. The first area was 0. See,
oh, right. Okay.
first
Okay.
rectangle
Fine.
has 0 area, no, for us.
Yeah.
Because
Fine.
we are
Okay.
taking the lower values, right?
Yes. Got it.
Right. So
Yeah.
this is the situation. So now
Yeah.
sum of first n squares, right? 1 square plus 2 square plus 3 square till n
The
square. There is a formula for it.
n into 2n plus
This
1
is the
into
formula,
6. Yeah.
right? This is the formula
Yeah.
for first n squares, right? But here,
Yes.
how many squares are there? First n minus 1 squares, right?
Yeah.
Right? So instead of n, I can put n minus 1. So n
n
minus
minus
1 into n into 2n minus 1 by 6.
1. Yeah.
Right? This is the final, if you replace n with n minus 1, right?
Yes. Got it.
So this becomes 8 by n cube into, what is it? N minus 1 into n into 2n minus 1 by 6, right? Correct.
Yes.
This is my
Yes.
final area of the n rectangles, right?
Yeah.
So let's cancel some, let's divide by n each term and remove the n cube, right? This n goes away. So this
Yeah.
becomes 8 by 6, 1 minus 1 by n and 2 minus 1 by n, right?
Yeah.
Correct.
Yes.
So okay, awesome. So this is my area value that is coming, right? Total area
Yes.
value of my rectangles, right? But
Yes.
this is always going to be wrong. There is an error in this, right?
Yeah.
So
Yeah.
if you simplify it, you can see it very nicely. So 2 minus 2 by n and
The n
minus
minus
1 by n plus 1 by n square, no?
12. Yeah.
So multiplied by 4 by 3, right? So you will
Hmm.
get 8 by 3 minus 4 by 3 into 3 by n. So 4 by n
4 by n. Yeah.
plus 4 by 3n square, right? So you're getting
Yes.
8 by 3 minus 4 by n minus 4 by 3n square, right? So you can
Again.
clearly see this area is slightly less than 8 by 3, right?
Yes.
Area of
Yes.
n such rectangles. So when you take limit n tends to infinity, area
Maybe
of
again that.
n, this will disappear, this parts.
Yeah.
It will
That will
become
be
8 by 3. Okay.
yes.
Now with confidence, now you can say that area from 0 to 2 of y is equal to x square is equal to 8 by 3.
8 by
Because this argument makes sense independently. No, even if you don't know any calculus, you can still do this. Makes sense, right?
yeah.
You are taking these rectangle areas and adding them up and then saying, I will not take these many rectangles, I will take infinite rectangles,
Yes.
right? So
Yeah.
it becomes very close to the real stuff, right?
Yes.
Correct. So now let's verify one. So we have got our limit n tends to infinity as 8 by 3, no? Now let's
Yeah.
verify something. So let's do x square dx from 0 to 2, right?
Yeah.
So what is the function? Let's guess now. So function is x cube by 3, right?
Yeah.
Plus
Yeah.
c and
Plus yeah.
0 to 2. Put the values,
8 by 3. Yes. Yes.
right? You are getting
Yeah.
8 by 3, no?
Yes.
So now this confirms for us what we have been suspecting, that this integral thing, right? This finding antiderivatives and putting values and finding the difference will give you the actual area under the curve from 0 to 2, right?
Yes,
Okay.
totally.
So
Totally.
so actually people found, so now how to actually get the formula for sine x, right? Integral sine x dx, right? Correct.
Oh,
So
minus. Yes.
integral sine x dx would be area under the curve from some place to some place, right?
Yeah.
Right.
Yeah. Yeah.
So one second. So what I want you to think about is, let's say sine x, right? Sine x is
Mm.
this graph, right? Correct.
Yeah.
Let's
Yeah.
focus our attention on only this part, right? Let's focus our attention till 0 to some point here x, okay?
Yeah.
Some point
Okay.
here x, 0 to x, okay?
Mm.
Correct. Or you can
Yeah.
also call it, let's call it some h or something. Let's call it h, okay? 0 to
Okay.
h, right? And
Okay.
I want to find the area under this curve, okay?
Mm.
Area under the sine x curve, this y is equal to sine x, okay? From
Okay.
0 to h,
Yeah.
okay? Now pretend for a moment that you don't know the guessing answer. You understand?
Okay.
Pretend for a moment that you don't know this, that it is equal to minus cos x, right? Forget about this for a moment, okay?
Okay.
You understand? We know it,
Yeah.
right? And we
Yes.
can just put 0 and h here, right?
Huh.
0
Yeah.
and h here, and we'll just say minus cos h, minus minus plus cos 0 is 1. So answer should be 1 minus cos h, right?
Yeah.
Right?
Yeah.
That
Yeah.
should be the answer to this, right?
Yeah.
But now we will not know this, suppose we didn't know it, right? So again, I will follow my regular method of doing it, right? This is a sine x curve. I have to find it from 0 to h, right? Correct.
Yeah.
I will split it into many such terms.
Mm.
You understand? N
Yeah.
terms, and each
And
term has width. H by n is my rectangle width.
yeah.
This is the
Yeah.
rectangle width. The first term comes at h by n. Second term comes at 2h by n, right? Third
Yeah.
is 3h by n, and so on, right? And
Yeah.
I will find out the height of each rectangle. So first rectangle is 0 height. Second rectangle is sine of h by n, right? Because this is sine h,
Yeah.
correct?
Yes.
So
Yes. Fine.
second rectangle 2, height is sine of h by n, and
Yeah.
width is h by n, right?
Fine.
Correct.
Yeah.
Third rectangle, height is sine of 2h by n, and width is still h by n, right?
Yeah.
And so on. Ith rectangle, height will be sine of I minus 1 into h by n, and
Fine.
width is h by n, right?
Yes.
Correct. So now
Yeah.
try to find the summation of this series. I goes from 1 to n, sine of I minus 1 h by n, right?
Yeah.
Multiplied by h by n, right? Correct. So h
Yeah.
and n are constants and all, so they can come out. So this is h by n outside. I is equal to 1 to n. Try to find the summation of this series and follow. Once you have found the summation of this series, after that you have to take a limit of n tends to infinity, no, to find the actual area, right?
Yeah.
Whatever comes as the sum of this series, right? You have to take
Yeah.
limit of n tends to infinity at the end, because you have to make many such rectangles, right?
Yeah. Yeah. Yeah.
Right. So
Yes.
I'll give you
Yes.
5 minutes. What you should do is try to find the sum of this, like write it down, just figure out how to find the sum of it, revise your trigonometry stuff. We have learned how to do the sum of this, okay? If you have forgotten, go back to your trigonometry booklet, see there is a summation of sine series and all. So 5 minutes you have, try to find the sum, okay? Okay, you understand the question, what we are trying to do, no?
Yeah.
You just have to find the sum of this sine thing, right?
Yes.
Go back to the motion book. If you have forgotten, it is there in that motion book, summation of
Yeah.
trigonometric series. Remember that last section?
Yeah. Yes.
So
Yes.
try to use that and get the final answer, and try to see the limit. I will do it in 5 minutes. I will be back in 5. Okay.
Okay.
Okay. Okay, are you getting anything?
I saw, but then where what concept, what is alpha, what is beta, and that bit confused.
So that is why you need to practice the trigonometry part. Okay, so this is limit n tends to infinity, I is equal to 1 to n summation of ai, right? So
Yeah,
your each area was, your summation was looking like this: h by n summation of I is equal to 1 to n sine of I
sine I
minus 1 h by
with
n, right?
H. Yeah,
So what does this look like? Let's write out the sum, the terms of the sum properly. So this is, first angle is sine of 0 into h by n, right? Plus second angle is sine of h by n, right?
yeah.
Third angle is sine of 2h by n,
But
and so on till sine of
sine
n minus
and
1 h by n, right? This
yeah,
is the thing, no? Now in that
yeah.
formula, if you understood the formula, you would have noticed that the angles are in AP, right?
Variables are in AP. Yeah, correct. Yeah, yeah.
The formula is like this: alpha plus beta plus sine alpha plus 2 beta,
Just to, yeah,
and so on till n terms, sine of
yeah.
alpha plus n minus 1 beta. The
Yes.
formula says it is equal to 2 sine n beta by 2 by sine beta by 2 and sine of first angle plus last angle by 2. 2 alpha plus n minus 1 beta by 2. This is the formula, right?
Yeah. Yeah.
So now first angle is what? 0 into h by n, right? 0.
0. Yeah.
Right? Last angle is this,
Yeah.
right?
Yeah.
Correct. And
Yes.
common difference is what? H by n.
Yeah.
So what is my alpha? Alpha is 0. Beta
Alpha
is
is
h by n. Alpha is what?
yeah, that is the first term. Yeah.
Beta is h by n, right? And first angle, okay, now we know everything. Now the answer of this series will be 2 sine n times beta by 2, right? N times beta by 2 is h by 2n.
Yeah.
By sine beta by 2. Beta by 2 is h by 2n, right?
Yeah.
Into sine of 2 alpha. Alpha is 0. N minus 1 into beta. Beta is h by n by 2, right?
Yes.
So this becomes 2 sine h by 2, right? And this becomes sine n minus 1 h by 2n, right?
Yeah.
Right?
Yeah.
This is n minus 1 h by 2n divided by h by 2. This is sine h by 2n, right?
Yes.
Correct.
Yeah.
So, and you have to multiply by h by n outside.
Yeah.
Correct.
Yes.
This is my summation, right? This is my summation thing. So now think about it a little bit here. So this n I can divide here, no? So I will write it once more. 2 sine h by 2, right? Multiplied by sine n I can divide inside. So I'll say 1 minus 1 by n into h by 2. See, this is the same thing,
Yeah.
right?
Yes.
Divided by sine h by 2n, right?
Yeah.
Correct. And
Yes.
multiplied by h by n. Correct.
Yeah. Yes.
Okay. So, okay, awesome. And now we have to take the limit of this. Limit of this as n tends to infinity, right? Correct.
Yes.
So,
Yes.
okay. Okay. So, let's do one thing. This h by n is there, no? See, h by n value becomes very small, no? If n tends to infinity.
Yeah.
So this h by n is a multiplication here. So let's write it as 2n and 2 by 2, right? H by 2n I will make it, right?
Right.
So I'm going to just write it as h by 2n into 2, right? Okay.
Yeah, fine.
Why have I done it? Because there is a sign of h by 2n here, right? So
The limit.
I will bring it down. I will bring this down like this. I'll write it like this, h by 2n.
Oh, so that becomes 1.
Because yesterday we have learned that, no?
Yeah, that becomes 1.
So this part is gone. There is a 2 here, right?
Yes.
Right? There's a 2 here, and this part becomes 1. So now there is no problem. So now it becomes 4 sine h by 2, and limit of n tends to infinity becomes, this becomes h by 2 only.
Yeah, h by 1. Yeah.
So sine square h by 2.
Yes.
Correct. 4 sine square h by 2. Now, double angle formulas you know, right?
The sine 2 with one thing. How did that came down. Okay.
Right, that came down. So this will become 2 sine square h by 2 is what? 1 minus cos h.
1 minus cos h.
Right?
Cos h, yeah, because it's h by
1 minus cos h. So
cos h.
I think we have made some silly mistake because of which this extra 2 is there. So, right, you understand? So this has become 1 minus cos h into 2. Some silly mistake has happened where the 2 factor, 1, 2 should cancel. Wait, let's just check once. 2 is here. So h by n, all of this is fine. This is fine. 2 sine. Hey, is there a 2 in the formula? No 2 is there.
One second.
Check the formula.
Yeah, it's like sine n beta by 2 by sine beta by 2 into
So no
sine
2 is
alpha
there.
n minus 1 by 2.
Correct. So no 2 is there, so no problem now. It is just 2 sine square h by 2, no?
Yes.
So this is 1 minus cos h. So now, notice that we have, after so much work, we have figured out that area till this point h, right?
This one. Yes.
Under the sine x curve, y is equal to sine x curve, right? Area till that point is equal to 1 minus cos h, right?
Yes.
Right? And that we can write, this is from 0 to h, we can write it as cos 0 minus cos h,
Yeah.
right? So
Yes.
now it gives us a hint that
1.
this can be written as minus cos h minus cos 0, right?
Yeah.
Right? So area is equal to area at h minus area at 0, the function. So this is minus cos h minus cos 0, that is 1 minus cos h.
Yeah. Yes.
You understand?
Yeah.
So my function that is the derivative is minus cos h, right? Or minus cos x, right?
Yes.
You understand?
Yes. Understood.
We got 1 minus cos h, no? And then now we know why the antiderivative was minus cos h.
Yes.
Because that function, if you put from 1 point to 1 point and subtract, you get the correct area, right?
Yes.
You understand? So
Yeah.
people have done this for difficult functions. So for example, 1 by x, suppose, right? Now nobody will believe it if I say that this is equal to log x.
Yeah.
Right? It is not easy to believe it, right? But
Yes.
people actually did the 1 by x function and found the areas properly, right? And once they found the areas properly, it turned out to be log x. Okay. So that is why derivative of 1 by x is derivative of log x is written as 1 by x.
1 by x. Yeah.
And so now you can guess this because you remember the derivative formula, right?
Yeah.
You are able to guess this only because you remember the derivative formula, right? But eventually somebody for the first time, somebody would have had to figure it out. Okay, what is the derivative, right?
Yeah.
So first time the figuring it out would have happened using this area thing. You understand?
Yes.
So later you don't want to repeat it all the time. All the time you don't want to do so many areas and summation and then limit, right?
Yes.
So later we will now when we do integration, what we'll do is we'll remember the set of values, antiderivatives, right? We'll remember that sine x integral is minus cos x. But you understand the real meaning behind this. Meaning behind this is the area under the curve, right?
Yeah.
And we have done the full proof for it. Okay.
Yes.
There's no doubt in why it is this. Okay.
Yeah.
And it is not just a guessing thing now. Okay, oh, because I knew derivative of cos x is this, that's why I said, right?
Yes.
Okay. So now you can possibly, if you want, you could have figured out yourself without even knowing the formula what is cos x dx by doing this process, right?
Yeah.
You understand?
Yeah.
So the process is independent of your knowledge of derivatives, right?
Yes.
And the process depends on finding the sum of the areas and then taking a limit.
Yes.
Okay. So you understood. This is the logic behind integration. Now all you have to do is remember these some basic formulas. 9 or 10 formulas are there, right? Which will be there in your sheets and booklets and all, right? And after that, it's about techniques of integration. So techniques of integration, that by that we mean what tools and tricks we will use to convert any given integral into this form. What tools and all we'll use to convert an integral into the form where we can use this formula. Okay.
They taught like 2 or 3 ways, like by substitution and by partial fractions.
Partial fractions you can ignore right now. Don't worry about partial fractions. But substitution method and integration by parts are the 2 main methods. Okay. So by parts, did they teach integration by parts?
Yeah, they did.
Okay, so 2 main methods are integration by substitution and integration by parts. So
Like there are many problems based on that they gave.
okay.
I got only like 2 out of 8.
How many questions, how many classes has happened for integration?
So finished it in one class.
Okay.
Not even one, like half.
Okay. Okay. Did they explain anything about this area under curve, anything?
Like they just said that it's given by definite integration, and we did like this part in physics, a bit of it. Like area under velocity curve, like this curve, and
But
it
nobody
can be
explained how it comes. No?
no, one.
None of this stuff.
Yeah, nothing like that.
None of this was done in class.
No, it wasn't.
Okay. 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 So they are just not doing justice to the subject and to the student. So they are just randomly just going over topics and all. So don't worry about it. Ultimately, you have to understand the real meaning behind things, right? You cannot be like, I know superficially, and somebody has told me, and I'll believe it, right?
Yeah.
So that is not the way to study. Anyway, integration by substitution and integration by parts are major techniques, and substitution method, basically what you have is, suppose, give me some example problems that you're not being able to do. Tell me.
Yeah.
Uh,
It's like one second. Yeah.
hmm,
Integration of e to the power root x,
hmm.
sine root x,
Sine root x, huh?
yeah,
Dx.
by the whole divided by, yeah, dx whole divided by 2 root x.
Okay, this is combining both of them. Okay, this is combining both the things. So I mean, can you give me a example? Okay, fine, I can do this, but do you know integration by parts?
Yeah, the formula, yes.
Okay, so first we'll do substitution. So right now this root x is bothering me a lot. Okay, so substitution method is basically a change of variables. So if I take root x as my t, right? Okay, so it's a change of variable to make the integral look in one of the standard forms that you have seen. Okay, that is what is substitution. Okay,
Yeah.
so
Yes.
so I will try to remove this root and all, because that is annoying. So I will do root x is equal to t, right? So I have a dx here, so I have to differentiate and get a dt. Okay, because if my integral is in terms of t, then I cannot have a dx there, right?
Yes.
So I should have differentiation of this will be 1 by 2 root x dx is equal to dt, right?
Yeah.
So dx is equal to 2 root x dt, right?
Yeah.
So dx can be written as 2t dt, right?
Yeah.
Correct.
Yes.
So
Yes.
or you don't even need to do all that. Dx by 2 root x is equal to dt, right? So dx by 2 root x, right? So this becomes e power t sine t dt, right?
dt.
After you do the substitution, right?
Yes.
So this substitution part of the question is over. Now it's about integration by parts. So integration by parts generally happens like this. So suppose you have to integrate something which is u of x and v of x, okay?
Yeah.
Multiplication of two functions, okay? You have to integrate. Now, the rule is that out of the two functions, one of them might be easy to integrate, one of them might be hard to integrate, okay?
Yes.
So the hard to integrate function is called the first function. Okay, first function, let's say u. Suppose u function you are unable to integrate immediately. Okay, this is hard. Suppose. Okay, and vx is easy to integrate, right?
Yes.
So then what you should do is take the ux as the first function and vx as the second function. Okay.
Yes.
So here, suppose actually here both of them are easy to integrate. So you can take e power t, suppose, as first function. Okay. Correct. So so the formula is keep the first function as it is. This integral is equal to keep the first function as it is, integrate second function, Okay, correct. Minus integrate derivative of the first function,
First function.
derivative of the first function, and whatever came as the answer of this integrating second function.
Yes.
Okay, and
Yeah.
dx. So basically, keep the first function as it is, integrate second function, minus integral of differentiate first function. The reason we chose first function as ux was because ux was hard to integrate. So the function that is hard to integrate, we will differentiate that, right?
Yeah.
So differentiate the first function, and whatever was easy to integrate, we have integrated and gotten some answer here, and we'll put that here. Okay.
Yes. Got
So
it.
we will try to do this for e power t sine t. So let's do it. So integral of e power t sine t. Let's take first function as u and this is as v. Okay. So then we'll say keep the first function as it is, e power t. Integrate second function. Integration of sine t we know is minus cos t.
Minus cos t.
Right? Minus differentiate first function, which is e power t differentiation is same as e power t.
Yeah.
And whatever answer came from integrating second function, this is minus cos t.
Yes. Yes.
So this is the thing, right? So now what happens is this becomes minus e power t cos t plus integral of e power t cos t, right?
Cos t.
Now again it is a similar problem, right? We don't know how to do this, so we'll do it once again. Integral of e power t cos t dt, again integration by parts. Okay, so now it will become what? See, keep et as it is, integrate second function sine t minus differentiate et and keep sine t, right?
Sine t. Yeah.
This is what is coming answer of this, right?
Yes.
Right. So I will substitute that answer back here. So it becomes minus e power t cos t plus e power t sine t minus integral of e power t sine t, right?
Yeah.
Right. But what was on the left hand side? This was equal to this, no?
Yeah.
So see, same thing has come here also and it was here also.
Yes.
So bring it to that side. So it is 2 times integral of e power t sine t is equal to minus e power t cos t plus e power t sine t. So integral of e power t sine t therefore must be equal to half e power t sine t minus cos t. Right? So this question happens by 2 times integration by parts. What happens first time? It becomes a different integral et cos t, and then once you do second time it becomes the same integral as the original integral, right?
Yes.
And same integral has come on this side, so you can put it on that side and say double of that is equal to this, right?
Okay.
And therefore you got the answer for that, right? Correct.
Yes.
And now put back your t substitution, what you had done, because that is something that you did, right? It was not in the question. So I will say sine of root x minus cos of root x, right? This will be the answer. Okay. So this is complicated stuff. It cannot be done in one class. What you should do for practice is go to R.D. Sharma or some standard book and integration chapter and start practicing from there. 11th or 12th, I think it will be in 12th standard.
12th standard.
12th standard R.D. Sharma book, you can, or NCERT book also is fine. NCERT book, just go and do the integration sections there. Only then, if you practice for a week or so, then you will be comfortable with it. Tell me another few questions. I will solve and show you.
Yeah. One more is integration of x into e to the power x.
That's it.
Divided by x plus 1 whole square. And whole thing dx.
Whole things dx, right? So, okay. So they are giving all the. This is almost like a maths class, no? Like integration, 12th standard integration class. But they should not be asking you these things immediately right now, like because you have just done one class. No, how will you be able to do it? Anyway.
And that topic is over. Like, so I was not going to do it again.
Okay. So ultimately you cannot do it right now so easily. You will not be able to get it. Its integration is much harder than differentiation and everything. So It's about practice and more practice, then only you will get it. But fine, I will show you this. Okay, so e power x, x can be written as x plus 1 minus 1,
Yeah.
right? Okay,
Yes. Yes.
so now see, e power x I am taking outside and splitting the fraction like this: x plus 1 by x plus 1 whole square minus 1 by x plus 1 whole square, right?
Okay. Yeah.
Okay, so this becomes integral e power x of 1 by x plus 1 minus
Yeah.
1 by
One
x plus 1
x
whole square.
whole. Now
Okay,
we can take x plus 1 as t or something. Or
so wait, so this thing, no, this thing is a standard thing. So whenever you have something like this, e power x f of x plus f dash x dx. Okay, see, can you notice that if this is called f of x, what is in differentiation of f of x?
minus 1 so minus 2. Oh, it's that one. 1 by x plus 1 whole square.
So this
That
is,
one.
isn't this, right?
Yeah. Yeah. Yeah.
Right?
Yeah.
Whenever you
Yes.
see this pattern, no, the answer is always e power x f of x. Integration
Oh.
of this is going to be e power x f of x. So you should be able to spot the pattern. That is what your skill will be. So we'll do a proof of this. How will it come as e power x f of x? Let's do a proof for that. So let's do integral of e power x f of x plus integral of e power x f dash x, right? This is the thing, right?
Okay.
So this is what it is, right? So we'll say
Yeah.
this is e power x f of x dx plus integral of e power x f dash x dx,
X
right?
dx. Yeah.
Right. Now let's
Yes.
focus our attention on this one. Okay. So okay. So let's focus on this one. So okay. So by parts we'll do this. Okay. We'll do this one by parts. Okay. So first function is u and second function is v, right? This one.
Yes.
U is e
Yes.
power x and f dash x is v. So let's
Yeah.
write it. First function, I'll leave it untouched. What is the integration of f dash x dx?
Integration
Of
fx.
integration of a derivative will be same thing, no?
Yeah.
Right?
Yeah. Yeah.
Minus integral of
Yes.
e power x into fx, right?
Fx. Yeah.
Right?
Fx
Correct.
dx. Yeah.
So
Yes.
the answer comes as of this part comes as this, right?
Yeah. Yeah.
And this cancels the first integral.
So it's e x to the power x. Okay.
You understand? So
Yeah.
if you do integration by parts on the second one, it will come as e power x fx minus the first integral. So this one will cancel this one. So this is always going to be this. Okay. So
Yes.
here, as soon as I saw x by x plus 1 square, no, I knew how to do this so that I can split it like this and it becomes this, right? And now
Yeah.
I notice that this is f of x and f dash x plus f dash x, right? So the
Yes.
answer is just e power x into f of x.
Right. So it's e power x.
Only if you know this will you be able to say the answer quickly, right?
Yeah.
E power x into f of x plus f dash x dx will always be e power x f of x integral, right? So just write it down. I mean, is this mentioned in your book or something somewhere in your FITG booklet or something?
Standard formula with it. Like many of them.
Is this
Like
mentioned? Is this part?
no, this wasn't there. This wasn't
Okay. Okay then.
there.
Okay, so this is the way to do it. Tell me another question.
Yeah. That is like if integration of e to the power ln f of x
Mhm.
dx equals to x to the power 4 by 4 plus c, find f of x.
Okay. Okay. Fine. So e power ln f of x is what? E power ln. Ln means e only, no?
Yeah.
it is just f of x dx, no?
Oh. Uh-huh.
Right?
Yeah.
Because e power ln 2 will be what? 2, no?
Two.
Because
Okay.
e power log e2, right?
E.
That is 2.
Yeah.
So this is just integral fx dx is equal to this. So
X. Yeah.
if you want to find f of x, why don't you take a derivative on both sides? Right?
X.
Because integral and derivative will cancel each other out, no?
Yes.
You understand? They are opposite operations, right?
Yeah.
So you'll get f of x is equal to x cube. That's it.
X cube.
4x4 by 4x cube by 4.
Yes.
So the thing to notice there was that this is an integral fx dx, and after that you can cancel the integral by doing a derivative on both sides, right?
Oh, fine.
Next.
Yeah. Next is integration of sine of cos e to the power x.
Like this.
Yeah. Into sine of e to the power x into e to the power x dx.
This is the thing.
Yeah.
Okay. So now this is a nice question, because this is a question that is doable by 11th grade people. Like when you have just started out, this is doable because this is a substitution question. Okay. So see, this is really horrible, this part, right? Why don't you take it as t?
The whole cos e to the power x.
Cos of e power x. No, it is cos of e power x, right?
Yeah.
Let's take it as t. Okay. So when you differentiate it, how do you differentiate this? Minus sine e to the power x into e power x dx is equal to dt. So now see, so nicely sine e power x dx is becoming minus dt. And this becomes sine of t. So it is minus sine t integral, which is cos t, right? And cos put cos instead of that.
Yeah.
This is the answer. You understand? This is a doable question because this is just about spotting what to substitute. See, generally when you solve questions in integration, the first thing you should try is some substitution. Some substitution might make it easy. Okay. So here it is about spotting that if I take cos e power x as t, then this part and this part will come in with the dx, right? The whole thing becomes very simple. This becomes minus dt, see?
Yes.
And this becomes sine t, right?
Yeah.
So
I was trying with e to the power x and I was not getting.
E power x also you could have gotten. So wait. If the integral is sine of cos of e power x, and what was here?
Sine of e power x
and e power x
into
dx. So if you take e power x as your t, what happens is e power x dx becomes your dt. So you get sine of cos of t sine of t, and e power x dx becomes your dt.
Yeah.
You can still get it. It's just about two steps now. Take this as u. Okay. Take cos t as u. So minus sine t dt is equal to du. So sine dt becomes sine of u minus du. So this is the same thing. This becomes cos u. Now put back everything. Cos of u is what?
So u was cos t.
And cos of.
Okay.
So this is just, you could have still gotten it. You just have to go two steps. And in that way, we did just directly one step. That is the only difference.
Yes.
Right?
Fine.
This substitution method you should practice a lot. That is the thing that will be more useful. Integration by parts is finally you have to learn it. So, but very rarely do you use integration by parts in 11th grade stuff. Like only in the real math section of calculus will you find this. So in physics and all, you'll not use. Sometimes you might. So might as well learn it. It's fine. So this is the slightly more advanced method. By substitution, you have to practice. So what you should do is go to Adi Sharma and or NCRT and practice enough questions of integration. Only then will this chapter become fine. Okay.
Yeah,
So
I started today. I
yeah,
started integration and derivative
correct.
today.
So that's it for now. And on Friday, what we'll do is we'll revise our triangles and finish our triangles and trigonometry part. Okay. We'll do some questions on triangles on Friday. Okay. So please revise what we did in the earlier classes. Remember, we did a lot of properties of
Yes,
triangle derivations,
yes,
right?
yes.
So
I
we'll
will
do
do that.
some questions. We'll see what it is, and we will conclude that chapter on Friday. So that will be conclusion of trigonometry for us. Trigonometry will
Yeah.
be over, and then we will start straight lines and all because FitG is starting that. Okay.
Yeah. Okay.
So we'll start straight lines and coordinate geometry, and that will take us 1 or 2 months, and hopefully we'll be done with coordinate by then. Okay.
Okay. Fine.
So that is the plan. I'll send you the recording for this class.
Yeah.
Make sure that you
Yes.
go through the integral derivation and what we did and how to understand it properly, right?
Yeah. I will.
So that it is not like some fake stuff that you have learned. It's like
Yeah.
actual finally you figured it out, right? It should be like that.
Yes.
Okay.
Fine.
Okay. That's it. Bye.
Bye. Thank you.